Okay, thank you very much. Welcome, everybody. Yes, my presentation is about livable fossil energy-free cities, and I focus a bit on the Rotterdam energy project planning, what we have been working on the past few years. But to start with the livability part, livability has a lot to do with social capacity and also the costs of energy. And if we look at the energy costs of rental homes in the Netherlands, for instance, but in the rest of the Western world, it's not much different. We see actually over here that these are houses from the 70s, and they actually pay more energy to their energy bill than they have to pay to rent. So this is very important to notice, that there are some people who, it really matters to that they have a lower energy bill, so-called energy poverty. But it's not just for rental homes. Here we have also graphs for people who spend energy and in relation to their mortgage, what they spend on energy. And what you see is that in 8 years' time, from 2000 to 2008, this has doubled, and the expectations are that it will even rise faster than this. So energy is not apart from the CO2 issue, it's also very much an economic and a social, well, actually livability issue. Well, here we have used GIS mapping. We are starting to use GIS mapping a lot in our studies right now. And this is a map of the energy use per neighborhood in Rotterdam. And here below is a map on the income of people in the same city. And when we combine these, we see that in certain areas, the light green areas, people already pay 18 to 19% of their income to energy. And one of the papers I studied mentioned that at 20%, you really talk about energy poverty. But I mean, 18 to 19% in this quantity in a city like Rotterdam is so much that we really take action on this. So this has been quite important to get this on the agenda. And of course, there are solutions which we can take, like smart meters, insulations, lower rent, green loans, and have actually lower rents for these people, and also a lower energy bill. Of course, we want to scale up energy. We have started with energy in buildings and energy positive buildings in the late 90s in Freiburg. And now we go to neighborhood level and to urban level. So actually to do this, we followed the structure which was presented by Professor Andy van der Dobbelstein in the city, and we studied the reduction of demand. So we looked at each household or neighborhood typology, houses from the 30s, from the 80s, from the 90s, and we knew which kind of energy households they have and what the reduction of these household typologies are. Of course, we always want to have more precise data, but this was a roughly guess, a best educated guess. And then we also knew the quick wins in the buildings from the 60s, 70s, and 80s, so where we had to start for these neighborhoods. Another step was actually to go and look at the exchange of energy waste flows, where we have, for instance, here a standard building from a certain era, to insulate it and then have a reduction of energy demand, and then reuse its waste flows like hot air, which is leaving the building, by taking the heat out of hot water. But looking at this, which was an interesting study by Andy, we said, well, if we have this, why don't we scale this up? Why can't we use the same trick, what we do within the building, between buildings? So look at different programs in the city, and then when we've done that at neighborhood level, we can also exchange between neighborhoods or between districts, so that we can actually scale it up and make energy part of planning, because there's a huge gap between energy and planning. One of the things we looked at was, for instance, that a supermarket, 1 square meter of supermarket, has enough waste heat to heat 1 square meter of apartment. Or the ice skating rink swimming pool example, which has already been given, is a ratio of 1 to 3. But also the greenhouses, which I think is very interesting for future city development. A greenhouse on top of the roof can count for 1 square meter of greenhouse, has enough heat production in summer to heat an apartment of 4 square meters. So you can have a 4-layer apartment with one greenhouse on top of it. That is with seasonal storage, of course, because you have to store the heating which is produced in summer and use it in winter. For instance, with heat-cold storage or huge boiler systems. So if we look at what has been done so far is that we usually went to the building level, right here down below, then reuse waste flows, then use renewable production, and then clean, efficient fossil energy. But with this system, with scaling it up, we can have actually different routes and actually first reuse the heat waste flows at neighborhood, district, and then city level. And then the last step would be renewable production, so that we completely fully use the waste flows which are existing in the city. So if we do this next step, this exchange of waste flows in the city of Rotterdam in this case, we have been looking at the district heating network. There is a potential of 2,000 megawatts, which would be enough for 1 million households. But of course, this energy is derived from fossil-based waste flows. So what if these waste flows get less? So we have been thinking of replacing these fossil-based waste flows, which is hot water in this case, by feeding it with geothermal energy, so that if there is a district heating network that is actually just hot pipes very well insulated in the soil, we can replace the feed-in of this with geothermal energy. So how the system now works is actually that we have a power plant, for instance, or where there's a lot of waste heat. They produce electricity, and heat is just wasted, and then the hot water goes to the homes. Usually they are new buildings because these are the ones they can connect easily, but they don't need that much energy anymore because they are well insulated already. And then the cold water goes back to the industry where it's used again for cooling. But if the water is not cold enough, the industry or the power plant can't do much with it. So what we try to do is actually make a smart grid for heating and cooling, so that we have the waste heat transport not just one way, but that the hot and cold water can be fed with different people consuming it and producing it, and also connecting not only new homes but also old homes, which much more needed. So this is a next step, and that's the REAP2 study we also did in Delft with DWA and Dubbel Strijkers architects, where we, for instance, looked at being the district heating network, which is existing, and then cascade it down. I will show an example of that in a moment. But also have, for instance, in this area, we have a medium temperature island where you have exchange between supermarkets or greenhouses and apartments. So it will actually be a mix of a central network, a local network, and some autarkic units which are fully providing themselves. So if we look at this figure which was drawn, is that, for instance, this is the 19 degrees Celsius heating network which goes into a building or a whole neighborhood. Then 17 degrees Celsius water comes out, goes into this neighborhood, goes to 50 degrees, 30 degrees. So this is the cascading principle, actually reusing this heat. When we exchange between, for instance, a supermarket and an apartment, it's quite possible that the supermarket only can provide 35 degrees Celsius of hot water. But if this building needs more, this needs more hot water than the 35 degrees being sent from the supermarket, then we can have a heat pump installed here and actually upgrade the heat left over from this system. So it can be much smarter than we have been doing so far. In this study, so we came up for the district heating for existing buildings is to cascade it, to exchange it, what I just explained, and to have self-sufficient, and then it was worked out in different typologies. So we had now reduction of demand, exchange of waste flows, and then there's this, of course, the renewable production with these energy potential maps, mapping, which has been done a few times with colleagues from University of Delft and even Dobbelsteen. And in Rotterdam, we tried to do this for also the Lijnbaan area, and we looked actually at the solar potentials at the roofs, but we also combined the data we had there with the housing owners, with people who already started putting solar PV on their roofs, so that we had people already active in this field to use them in consultation rounds, etc. So we're now trying to scale it up and put it in a process, to make things happen. Energy scenarios for existing neighborhoods, that would be a next step, because at neighborhood level we noticed that many people are active. And if we look at the transition we are expecting from these two studies we did, it's kind of patchwork between central and decentral. Electricity, which is fed by solar, wind, geothermal, biomass, and others. And heating, especially district heating, heat cascading, low and medium temperature networks, autarkic blocks, also biomass, wind, and the rest of the renewables which are in place. And actually, to plan for this is very difficult. So what we have been doing so far is put data of the whole city of Rotterdam, of the primary energy for industry, residential, services, traffic, and energy production. And here you see actually the primary energy carriers being fed into the system, and we can actually play with this. This is a tool which is developed by Sebastian Carney. We can play with it, and we can actually see the change in CO2 emissions directly. So we don't have to calculate for weeks and weeks. We can use it in stakeholder environments where we, together with the stakeholders, define what the new energy mix can look like. But there's one problem so far. We have this. It's done for this is an example from Glasgow, but we've done this. It's been done for 15 other cities, but it's on a city and regional level. So what we try to do now is actually bring it back to neighborhood level. So again, we need the reduction potentials to feed in the figures for efficiency. We need the exchange levels and where do we want to bring the district heating. For instance, area with a high floor space index, areas near to the existing district heating network. So this, we notice that there will be a patchwork of different solutions in the city. And this also adds to the resilience in energy. If we only have one big energy system, when it fails, the power system fails, everything is down. But having this patchwork of different productions and use makes it much more resilient when there is a failure at a certain place. So this is the next steps we are going to take in the next 2 months. And with that, I would like to conclude my presentation. Thank you very much.